Good morning, pre-calculus. This is Mr. Stroh. I'm going to try to teach you guys about angles and radians today. All right. Some of you I had for geometry. We talked about angles before. Remember, this is what an angle looks like. We got 3 points. You start at A, you go to O, the vertex, and then up to C, and that makes your angle. And then we're measuring the angle, so that's the space in between. Now, in geometry class, we said that COA is the same as AOC. Those are two congruent angles, but we're going to be doing something in coordinate geometry. We're now on the Cartesian plane, and we're going to start measuring these. And I was trying to make it 45 degrees, but it came out to be 45.05. So the space in between the two rays is what we measure it, the way we measure it. The first ray we're going to call the initial ray, and then we go up to the terminal ray, which is where we stop. And so we're saying all the space in between those two rays is the measure of the angle. When we're measuring it on the Cartesian plane, you always line up the initial ray on the positive x-axis, and then the terminal ray ends up being somewhere. If it was acute, it's going to be over here in quadrant 1. If it's right, it's going to be up here on the positive y-axis. If it's an obtuse angle, you're going to have C be in the second quadrant, and then we got up to a straight angle, which makes a line, and that would be on the negative x-axis. But when we go into trigonometry, we're going to start having angles bigger than 180 degrees. So over here, you can see almost a 360. All right, let's see. Taking us to the next slide, we got coterminal angles. So now we have to pay attention to which direction stuff is going. If it goes counterclockwise, if it goes the opposite way of the clock, we're going from positive x to positive y. We're going this way. That's counterclockwise. That's a positive angle. And then if we go clockwise down this way, it's negative. So AOB in this picture is negative 90. Whereas AOC over here, AOC, we're going this way, that's a positive 90. But now, in this AOC and this AOB, they look to be the same angle. They both look like right angles. They are both right angles. But the difference is, on AOC, you can see from this little diagram right here, it just goes directly. It doesn't stop. This one, you did a loop around the block. You did one rotation, and then you came back up a little bit further. It's like a spinner. If you spin a spinner, you don't care how many times it went around. All you care about is where it stopped. So to find coterminal angles, we just have to add in rotations. And now a rotation is 360 degrees, until we're going to find out it can also be 2 pi, but that's here in a second. So I want 360 degrees plus 90 more makes 450. And then if you look over here, negative 90 is the same thing as positive 270. And if I add 360 to negative 90, I get 270. Or by the same token, if I take 270 and subtract 360, I get negative 90. So to find coterminal angles, all you have to do is add rotations, which for us right now is 360, but in about 30 seconds will be also include 2 pi. So here's one rotation of a circle. We call that 360. That's kind of arbitrary. I could get into why, but I only have 5 minutes, so I can't. For over here, now this is a circle with radius 1. So that means that the circumference, the distance around here, is equal to 2 pi. So for degrees, we got BAC right here. We're just saying it goes from here to here. It didn't do a loop or anything. That's going to be 90 degrees. That's a quarter of the circle. But so that means a quarter of 2 pi is 2 pi over 4, which is pi over 2. So a radian is really measuring the length of that arc. It's now a very concrete measure. It is not an arbitrary 360. It's the length of the arc in between the initial ray and the terminal ray.